Hello and welcome to Explanation of Optimizer Results. This series is aimed at supply planners and any other IBP practitioners. This is part 1. It introduces IBP explanation run with a detailed example. IBP Supply Optimizer produces cost-optimal supply plans while respecting all constraints. It transforms the supply model into a mathematical representation, called a mixed integer linear program, as only a subset of variables need to be integers. This mathematical model is proven to produce the best outcome, but the math involved is quite complex. This makes it hard to understand planning results, especially issues with demand fulfillment. IBP explanation run can be performed after the optimization run, to help planners understand the reasons for unmet demands. There can be many reasons for unmet demands. The potential reason types are shown here. IBP runs one explanation run per each reason type, hence we need to watch out for performance impact. Let's examine a few of these reasons in this series with detailed examples. Let's orient ourselves with the supply network used in this example. We will focus on two finished goods, IBP 100 and IBP 300, sold to 3 customers in the Americas region. Distribution Center 1720 serves all these customers. Plant 1710 supplies product to this DC 1720. Plant 1710 has an assembly resource to produce these two finished goods. IBP 100 only needs one raw material, IBP 103R. IBP 300 needs both raw materials, IBP 103R and IBP 303R. Two suppliers provide these raw materials to the Plant 1710. Let's review transportation lead times across this supply network. Customer source master data is used to maintain customer transportation lead time as 2 weeks from DC to customers. Location source master data is used to maintain transportation lead time as 1 week from plant to DC. In total, it takes 3 weeks to move finished goods from plant to customers. Suppliers are also modeled as locations. Location source master data is also used to maintain transportation lead time as 1 week from suppliers to plant. Let's also review production-related master data in the Plant 1710. Production source header master data is used to model production lead time as 1 week to assemble the finished goods. Production source item master data is used to model bill of material relationships. It takes 2 units of raw material to produce 1 unit of finished good. We will focus only on the raw materials to keep things simple. You can ignore sub-assemblies IBP 101S and IBP 301S for this series. Production source resource master data is used to maintain capacity consumption rate as 1 unit per each finished good produced on the assembly resource. Non-delivery cost key figure tells the optimizer the cost of leaving demand unfulfilled. We set this key figure as a high value for customer 1, customer 2 is lower, and customer 3 is lowest. This ensures customer 1 demands are prioritized over customer 2, and customer 3 demands are the last priority. Late delivery cost key figure tells the optimizer the cost of meeting demand late. This can also be used to drive customer prioritization in case of late supply, similar to non-delivery. Maximum late delivery periods for customer demand key figure tells optimizer the maximum delay allowed. Note that customer 1 is willing to take shipments up to 4 weeks late, customer 2 is only willing to wait 2 weeks, while customer 3 has a zero tolerance to delays. We have 4 demands in week 35 across the 3 customers and 2 finished goods. This equates to 1,000 units of capacity demand in week 32, given the 3 weeks lead time from plant to customers. We have just the right capacity supply of 1,000 in week 32. Hence, Optimizer is able to fulfill all the 4 demands on time in full. We introduced a capacity constraint in this iteration 1. 1710 assembly resource in week 32 is now only available for 500 minutes, instead of 1,000. See how planning results have changed. Customer 1 is still confirmed on time in full. Customer 2 is also confirmed in full, but 100 units will be arriving a week later than requested. This is due to the total capacity constraint of 500 in week 32. Optimizer is unable to plan any receipts for customer 3. IBP business log at the bottom of the screen shows the reason for unmet demands to be missing capacity in week 32. This is helpful, but does not provide a full explanation for unmet demands. For example, why did IBP not produce the needed supply a week earlier or later, as plenty capacity exists in week 31 or week 33. Capacity supply of 500 in week 32 is already fully consumed by higher priority demands from customer 1 and 2, this leaves customer 3 with no receipts. Remember, customer 3 does not accept late shipments at all, as max late delivery period's key figure is set to 0. So, producing a week later in the plant does not help customer 3. Customer 2 does allow late fulfillment up to 2 weeks, which is why we were okay to ship 100 units a week late. Let's get back to the question why IBP did not produce a week sooner, as there is no capacity constraint to produce a week earlier in week 31. Remember, IBP needs a week to ship the raw materials from the supplier locations to the plant location. We simply ran out of time to procure the raw materials needed to produce the finished goods in week 31. In conclusion, IBP Optimizer produces a cost-optimal finite supply plan. IBP explanation run helps identify reasons for unmet demands. However, the explanation run does not evaluate the impact of relaxing a given constraint across all the issues reported. For example, an unmet demand due to missing resource capacity may continue to remain unmet, even after increasing capacity. This is because the extra capacity gets consumed by other unmet demands of higher priority. GitaCloud has an optimizer explanation service that can help planners understand the full context and color of optimizer results. More importantly, we can help resolve master data issues and fine-tune the cost model to produce the desired results. See Part 2 of this series to understand the impact of lead time and supplier constraints on planning results. You can find all such videos in this SAP IBP Explainer series at GitaCloud website or GitaCloud YouTube channel. SAP IBP can transform your supply chain effectiveness across demand, inventory, and supply planning processes. GitaCloud can help deliver planner adoption and significant business value from your SAP IBP asset. Hope you enjoyed this video. Please like and share if you did. You can also subscribe to GitaCloud YouTube channel to stay on top of similar content in future. Thanks for watching. Have a great week.